So today we are going to start NumPy. So what is NumPy? NumPy is the fundamental package for scientific computing in Python. Okay. So you know that Python is one of the most powerful languages that we have to do programming in machine learning and data science, and also in deep learning. So NumPy is one of the fundamental packages of scientific computing. Like MATLAB is MATLAB is a scientific computing tool. So in MATLAB you have many options and many functions you can evoke, mathematical functions. Same thing can be also done using NumPy. Okay. So NumPy is a Python library that provides a multi-dimensional array objects, various derived objects such as marked arrays and matrices, and an assortment of routines for first operations on arrays, including mathematical, logical, shape manipulation, sorting, selecting, I/O, discrete Fourier transformation, basic linear algebra. So basic linear algebra, many operations are you can directly evoke in NumPy package. So those are very important tools that we can directly incorporate in our program. Basic statistical operations are also there, random simulation, and much more. So these are the benefits of using NumPy package. Okay. So whenever we are doing some machine learning programming, we have to use this NumPy package. You have to import this. So at the core of the NumPy package, it is the ND array. Okay, ND array object. So through this ND array, we can create matrix or array. You can call it array, 2-dimensional, 3-dimensional, not an issue, using this ND array object. This ND array encapsulate n-dimensional arrays. Okay, ND array means n-dimensional array. If you remember, in C programming, creating 3D array itself is a big deal. Okay, here you can create n-dimensional arrays of homogeneous data types. Homogeneous means similar type of data types with many operations being performed in compiled code for performance. Difference between NumPy arrays and standard Python sequences. Now you can ask me, sir, why we need NumPy? Because we can deal with 2D array and a 3D array in Python itself using sequences and all. We can do it, but using NumPy arrays things will be much more faster. Okay. So NumPy arrays have a fixed size at creation, unlike Python lists. So 2D array you can create using list, 2D list. Okay. So changing the size of ND array will create a new array and delete the original. So the elements in NumPy array all are required to be of the same data type, and thus will be the same size in memory. The exception, one can have arrays of objects, thereby allowing for arrays of different sized elements. So NumPy has many benefits. Okay, main object in NumPy is ND array object. NumPy arrays facilitate advanced mathematical and other types of operations on large number of data. So when you have large number of data for data cleaning, and then data, you call it data scaling, data normalization, and all those things also will be much more easy if we import NumPy array. Typically such operations are executed more efficiently and with less code than is possible using Python built-in sequence. Now if you can do similar type of things using Python list, but that will be much more cumbersome. Instead, you can, using NumPy array, especially this ND array object, you can do things very easily and quickly. So these are the main differences between NumPy arrays and standard Python sequences. Okay. Scientific and mathematical Python object package are using NumPy arrays. Though this typically supported Python sequence input, they convert such input to NumPy arrays prior to the processing. What it means that before the processing itself, they change the input to NumPy arrays prior to the processing, and they often output NumPy arrays. So whole data set that will be there as an input to the machine learning algorithm, that whole data set before processing itself they convert it to NumPy arrays, so that in future things become so much more easy to handle. Okay. So I was talking about the difference between NumPy arrays and standard Python sequences. Standard Python sequences also, it is good. I wouldn't say that is bad, because standard Python sequences also you can generate multi-dimensional array, not an issue. But in normally what happens in the data input that you will be taking for the machine learning algorithms, let us say support vector machine, using support vector machine you are going to predict something. So in that time your data set will be large enough. So on that situation you cannot deal the data with standard Python sequences like normal 2D list or 3D list, whatever. So in NumPy arrays have a fixed size at creation, unlike Python list. Changing the size of an ND array will create a new array and delete the original. The elements in NumPy array are all required to be the same data types. Using NumPy array we can deal with the large data, which is quite impossible using normal Python sequences. That is the main difference. And then scientific and mathematical Python based packages are using NumPy arrays, though this typically put Python sequences input, they convert such input to NumPy arrays prior to the processing. As I was mentioning, before the data processing itself, like data cleaning, data normalization, and data what do you call it, scaling, all these operations, before all this operation itself you have to convert the data into NumPy arrays, and they often output NumPy arrays. Okay, so these are the things we can do. And then so the simply knowing that sequence built-in sequences in Python won't help. We have to know this NumPy arrays. After knowing NumPy arrays, how to deal with NumPy, you also have to know Panda. That is next level packages we have. Next is why NumPy is so fast. NumPy is so fast. No, why NumPy is faster than other conventional functions or methods. Consider the case of multiplying each element of 1D sequence with the corresponding element in another sequence of the same length. If the data are stored into Python list A and B, we could iterate over each element like this. So normally if you go with the sequence Y is if you want to, let us say, multiply two lists, that you can do it with AI into BI. Okay, this is what you can do. And then in C programming, same thing you can do like this. In this procedure the correct answer, but if A and B each contain millions of numbers, we will pay the price for the inefficiency of looping in the Python. So Python here, multiplying two matrices, let us call it two matrices, will be little bit time consuming if you go with the normal range and then normal sequence way. C programming, however, it is little bit faster. C programming used to write like this, right? We could accomplish the same task much more quickly in C. In fact, if you go with Python multiplying two matrices like this, it will take much more time than this. In fact, C will be much more quicker. But in case of okay, and then in case of 2D array, for example, in C code we used to multiply like this. Okay, now in NumPy gives us the best of both. So NumPy will be as quicker as C and will be more quicker than this normal Python multiplying using Python sequences. Okay, so just here to that we have to write NumPy gives us best of both worlds. Elements by element operations are the default mode when an ND array is involved. Yeah, so in C it will be much more faster, but in case of Python it will be very slow. But in C, calculating two matrices is little bit difficult, and it is the you have to write more code for that. What NumPy does, NumPy take the both best version of the both. Okay, so NumPy gives us the best of both worlds. Element by element operations are the default mode when the ND array is involved, but the element by element operation is speedily executed by pre-compiled C code. So in NumPy you can write like this: C equal to A star B. That's all. So this C equal to A star B does what the earlier example do at near C speed. That means whatever speed C takes, C programming takes, NumPy used to take that much of time. Okay, not more than that. But with the code simplicity, yeah, obviously, because in C we used to write so much of code for multiplying two matrices. and in NumPy you have to just write c equal to a star b, that's all. Therefore the NumPy idiom is even simpler. This is how NumPy can help us. That means what they're trying to say, that the code, the background code is written in C. Okay, background code is written in C, executed by pre-compiled C code. You remember? So this has to be, we have to, but that means this package, the NumPy package, when you will be multiplying two matrices, the background code, the exe code that is written is actually C code. Okay, so that's why it is so faster. But anyway, once you write c equal to a star b, it will take not more time than what c takes, and it will be much more simpler than normal conventional way of multiplying two matrices in Python. So both way we have the benefits. Why is NumPy fast? First of all, NumPy uses vectorization. Okay, what is vectorization? Vectorization is used to speed up the Python code without using loop. That means you will get everything. It's like a pre-compiled functions or pre-compiled facilities will be available, so that quickly it will calculate. You do not have to write the loops and all. Using such a function can help in minimizing the running time of the code efficiently. Vectorized code has many advantages, among which few advantages are: vectorized code is more concise and easier to read. First of all, it will be more simpler, and it will be written in much more less syntactical. The complexity of the syntax will be less. Fewer lines of code generally means fewer bugs. That is also there. The code more closely resembles standard mathematical notation. It is almost like a notational representation. Okay, vectorization results in more Pythonic code. Without vectorization, our code would be iterated with inefficient and difficult to read for the loops. That is one of the reasons why Python is so much popular. Because every now and then new algorithm develops. The Python community, that means the fellow who develop the Python code and packages, it comes very quickly. Let us say if new algorithm comes, let us say somebody publishes a new algorithm, right? Let's say new version of convolution neural network. Immediately some guys or some coder, Python coder who actually expert, who are actually expert in machine learning, immediately they will add the community. They will inform the Python community with their most advanced compiled packages, so that others can download that packages and they can easily use it. That's why this language is getting so much popularity. That means community of Python is much more bigger, larger and strong compared to other languages like Java and C and C++. R also very popular language. R programming, R community also. Both are similar type of language only. Okay. Another important terminology in NumPy, that is called broadcasting. So if you might have some of you might have done some there are some good courses available online. Those courses, they used to mention this broadcasting concept. This broadcasting concept is nothing but a part of NumPy. So what is broadcasting? Broadcasting is a term used to describe the implicit element by element behavior of operations. Generally speaking, in NumPy, all operations, not just arithmetic operation but logical, bitwise, functional, etc., behave in this implicit element by element fashion. That is the broadcast. So when we write c equal to a star b, it's a kind of broadcasting. Okay. Moreover, in the example above, a and b could be multi-dimensional array. So this is a simple notation where a and b can be multi-dimensional array. That means a can be 2D array or 3D array, b can be 2D array or 3D array, even more than that. So that is called broadcasting. Okay. So multi-dimensional array of the same shape, or a scalar and an array, or even two arrays with different shapes, provided that the smaller array is expandable to the shape of the larger in such a way that the resulting broadcast is unambiguous. So if it is, let us say, 2 cross 3 matrix, if this is 3 cross 4 matrix, doesn't matter at all. 2 cross 3 matrix can be multiplied with 3 cross 4 matrix, let us say. So this is what broadcasting is. So broadcasting is the important concept. Vectorization is important concept. These both concepts are used in NumPy. Okay. So if you say what are the resulting takeaway from NumPy, I would say vectorization and broadcasting. These concepts are very popular, and these concepts are very strong concept. Okay. Who else uses NumPy? NumPy fully supports an object-oriented approach. That means it is supported by class and other facilities of class. Starting once again with NDRA. So NDRA is the main object in NumPy. For example, NDRA is a class processing numerous methods and attributes. Many of its methods are mirrored by function in outermost NumPy namespace, allowing the programmer to code in whichever paradigm they prefer. So the flexibility has allowed NumPy array, dialect and NumPy NDRA class to become the de facto language of multi-dimensional data interchange used in Python. That means de facto language means it is the only available tool we have in Python environment that you can use. Okay, this NumPy. Now students, how to install NumPy? So as we haven't discussed anything about Anaconda, many of you have already installed Anaconda and working on it, but you remember one thing, Anaconda is for that if you don't have anything with you, right? If you don't have Python installed in your Python exe not installed in your laptop or your system, and you don't have any editor or something like that, in that case you can use Anaconda distribution. In Anaconda distribution you will find everything in a single environment, and you can download, you can work on it. Okay, but we have already seen how to install Python 3.9, and then I think with Python 3.9 we have by default IDE is idle is already there. Okay, alongside idle you can also install the PyCharm. Okay, if you want I can show you PyCharm sometimes. So otherwise you can use Anaconda distribution. It is when Anaconda distribution these concepts will be requiring, we will be installing it. Right now we are doing simple things, so I don't think Anaconda distribution is necessary now. Okay, we can simply do programming on our normal Python environment, that is Python 3.9.1, and then with editor like idle or maybe PyCharm. Okay, so if you are using Conda Anaconda, then you have to type this Conda create -n my new environment, all this you have to type, and then finally install NumPy. But we are not using Anaconda right now, so we are using we are using normal Python environment, that is Python 3.9.1 version, and alongside we also have installed, most probably I have installed PyCharm, so I'll show you in PyCharm how you can do it. Okay, so we'll see, we'll go and I'll show you how to install NumPy in how to install NumPy in PyCharm. Okay, so what you can do, you can go to terminal. Sorry, one second. Yeah, terminal, it is not working. Okay, so you can go to terminal. As I shown you that you have to just write pip install NumPy. Okay, so let us copy this. Here you write pip install NumPy and then enter. Yeah, it has installed. Okay, already I have already installed, so it is already installed. Now once you do that, you can directly go and then this virtual environment we are using here, so in that situation pip install NumPy is okay. Let us do one or two program, then we will install, but then we will understand in a better way. So first thing is that how to import NumPy. Okay, in order to start using NumPy and all the functions available in NumPy, you will need to import it. Okay, this can be easily done with this import statement. What you have to write, import NumPy as NP. Okay, import NumPy as NP. So here NumPy is the package, we are importing it, and this NP is nothing but it's called alias. Okay, NP is an alias, so import NumPy as NP. NP is an alias pointing to NumPy. Okay, also by writing NP, that is short form of NumPy, in order to save the time and also to keep code standardized, so that anyone working with your code can easily understand and run it. So this is how we should import the NumPy. So import NumPy as NP. Okay, this is what you have to do. One second. One second, students. Okay. Okay. So one second. So this NP is nothing but alias. Okay, this you have to write every time while importing the NumPy. Now let us see how NumPy is actually benefiting us. As I said that NumPy takes lesser time than normal conventional sequencing programming. Okay, that we are going to see. So first we are going to see. You can write it here. What you can do, we'll create first one. We'll first create one NumPy. Using NumPy, we'll first try to generate NumPy array of 1 million integers. We will try to generate. Okay, 1 million integers. That means 10 lakhs integer we are going to generate using first using NumPy. Sorry, not this one. One second. This one. Okay, so here we are using NP. Before that, what you have to do, we have to import NumPy. So that has to go here. So import NumPy as NP. Okay, and this is my array variable where where we are creating this np dot arrange 10 lakh. Okay, 1 million integers, and then we are going to see how much time it takes. So what we'll do, we'll import time. So time is another package that you can import. Okay, import time and then start time dot time. So here we are writing start time dot time. This list, this you can delete. Later on we will also see how to do it with the same thing with the list. Okay, so this is this you can delete, no problem. So start time and then end time. So this start time here starts here, and whatever time takes by this syntax, it will be there, and then finally we are having end time. Okay, end time equal to, yeah, and then using this we can print this, what is the end time minus start time. Okay, so let us see how using NumPy how much time it takes. So it takes near about how much seconds, maybe this may be in seconds, 0.0003, and then this much of second, this much of time. Okay, whatever, we don't know exactly it is in seconds or microseconds, assuming that this is in seconds. Now we will use normal sequencing programming, that is using list. So what we will do, we will just simply copy this and we will print it over here, and now we are going to see how much time it takes. Okay, you see it is much more than the earlier one. That means truly NumPy has reduces the time. Okay, so it is now 0.01, which is much more than the earlier one. Earlier one was 0.002 millisecond, maybe millisecond. It is in millisecond. Okay, so it is in millisecond. Fine. So this is the this program tells us how much time NumPy actually reduces. So it's a considerable time. So for 10 lakh integers, this much of time it has reduces. So if the array size is more, data size is more, definitely this NumPy is going to help us. Okay, and then this is there. And then as I said that and then we can see what are the other things we can do. So this facility is available in Python 3.9, this F, and then writing this. Okay, so this facility is available only in Python 3.9. okay, that one is that using NumPy, another one is the using list. Okay, now let us do a little bit of programming. So let us generate some random data. Okay, sorry, generate some random data. Okay, so let's say data equal to, again we are using this NumPy np dot extension. Let's say random dot, this is an existing function, extension function is available, randn 2, 3. Okay, and then finally I'll be printing this. So print data. Now let's run it. So it's printing some random data, you see, it's printing some random data. So using random function we are doing it. That means these extensions are already available in random.randdn. This already is available in NumPy. Okay, then let's say then let us write mathematical operations with this data. Okay, so mathematical operations. So let's say this is our data, and then let's say data plus data, some operations. We are adding the same data 2 times, and then we are printing it. Let's say print so again we are, after addition, this is the outcome. Okay, so we can do many things here in using NumPy. Okay, and then there is and so this whole thing is called ND array. Okay, this is a ND array. This is an ND array is the object. Okay, ND array is the object. If you want to import everything from NumPy, you can write import NumPy import. Achha, that I'll come to later on. Fine. Let's deal with shape. There is another function called shape function. So ND array is a generic multidimensional containers for homogeneous data. That is, all of the elements must be the same type. Every array has a shape, a tuple indicating the size of each dimension, and D type, an object describing the data type of the array. So how this shape is actually happening? So let us say this one, data dot shap shape. Okay, this is another facility available. So if you print it, it will talk about the shape of the data. Okay, let us ignore these two. 2, 3. 2, 3 is the shape. Shape means mostly it is dimension. Okay, and then there is another extension which is called D type, which stands for data type. So what kind of data type it is? Okay, so for that we have to write data dot shape. You have right here, you have to write data dot D type, D type. So if you run this, it will say float 64. So this is the data type of this data that we are considering here. That what is the data type? Float 64. Okay, so and then we can see that how to create more and more array function. Easiest way to create an array is to use the array function. There is a function called array, direct function is available. Okay, this array function accepts any sequence like object and produces a new NumPy array containing the passed data. For example, a list is a good candidate for conversion. Let us say we are going to, let us say we have a list. Okay, let's say we have a list. This I am just let's say you have a list. Let's say data is a list. By this time you know how to write list. Data equal to, let's say 5, 6, 7, 8. This is a list. Okay, once you write like this, you know that this is a list, and let us call it data 1. And then let us convert this data into array. Okay, this list let us convert into array. So what we will do, let us take a double r array, a double r 1 array 1 equal to NumPy, using NumPy. Obviously using NumPy. Every time we will be using NumPy only. NP is the alias. Okay, a double r a y array, and then you just pass that data 1. That's all. This everything will be converted into array. Okay, now if you print it, let me see first here. Okay, so what you can do, we can just print it. Actually we are not doing it in terminal, that's why every time you have to print it. Okay, a double r 1. So this is the converted array. Okay, this is a converted array. So this is how NumPy will be useful. We can convert any list to array, and then you can do, let us say, nested sequence like list of equal length list. Let us say we want to convert it into a multi-dimensional array. Sequence is the list of equal length list. Okay, nested list. Okay, so for that what you have to do, for that let's say data2 equal to 2 list. I mean 2D array we are going to take, actually 2D list, not 2D array, 2D list. So one list is, let us say 1, 2, 3, 4, comma, and then another list will be, let us say 5, 6, 7, 8. Okay, so this is a 2D list. Let us convert this 2D list into an array using NumPy. So array2 equal to np dot a double r a1 delete then you have to print it, obviously, print print. So this is 2D list has been converted to array. Okay, so now we have seen how to convert the 2D list into array. NumPy, how powerful it is. So similarly you can also print the dimension. So for that we have a function called n dimension. Okay, so you have to write just that, let's say array2 you have taken over here. So here if you write, let's say array2 dot n dimension, and then if you print it, so dimension is 2 because we have taken 2 rows. Okay, 2 rows we have taken. And then similarly you can also there is a concept called n0. Okay, so n dimension, and then finally n shape also you can write. Let us say if you, instead of n dimension, if you write shape, shap, it will print 2, 4, because 2 rows and 4 columns are there, so that also is possible, shape. Okay, and then there is a concept called and data type also you can print data type. So you have to write d type. So I think I already have shown for one dimensional array. So d type you have to write. D type integer 32 in this. Many times we require to create replace values with zeros and ones. So NumPy supports zeros and ones creation. Okay, so just that you have to import NumPy as np, and then you have to write np.0 within bracket 10. Okay, and if you print it, all zeros will be created. So using this np.zeros we can create number of zeros. Okay, and let's say you want to create this zero specifically 3 rows and 6 columns. So for that, what you have to do, you have to write 0 3 6. Right, I just missed one bracket. So we can generate 3 rows and 6 columns. In fact, we can also generate 3 rows and 2 columns. So anything you can, any number of zeros we want, we can generate. Okay, so this is how this zero extension works.